welcome everybody to this session. It's a pleasure being here and presenting this line of work. So I will actually motivate the use of the Southmont models by jumping right into what we do in the paper, and then I'll give you a little bit the bigger picture where it sits in the larger work on environment that we do. Also worth mentioning, our colleague Olli-Pekka is back here, and he also will present later today. We have a lot of work going on in this specific theme, so I think very interesting work also coming forth. We'll also have a call later this year, so please stay tuned for that as well. We want a lot of really great submissions. So fuel subsidies, obviously has always been a big topic, and here you can already see I put down some numbers for the Latin American region overall, but also for the specific countries we'll look at in this piece of work. And obviously it's also been very much a very politically sensitive debate always about how to reform, whether to reform, and so on. But now increasingly, of course, apart from the cost, the question of what does it do to the environment comes into play, right? So a lot of countries are confronted with discussion about carbon taxes, but they actually have fuel subsidies in place, which is a bit counterintuitive, right? So I think all of us know about enough governments that have been toppled over fuel subsidies. And that, of course, then also means that the evidence, but also how we communicate about the evidence, must be handled carefully. Now, what we're trying to do in this paper is we're trying to give some numbers to what it means if you take away a fuel subsidy and what you could do in the system to alleviate the losses for those who are often very, very sensitive at the bottom of the distribution. And this is kind of the bigger line of work that overall we do at WIDER on this topic, is we're trying to understand more about the distributional impact of these policies. Because we all know we need support for such policies from across the distribution, but we do feel we don't understand enough yet how these things will actually spill over to which parts of society. So I'm not going to give the whole rundown on the literature, but basically you have a part of the literature that looks in a very simple terms at the direct static impacts of fuel subsidies. You often have literature on the price shocks and how that moves the needle or not. But mostly it stays at that level, and it doesn't go into understanding more how the production structure of the economy might also produce indirect effects. Like one thing is the fuel for my car is going to get more expensive if a subsidy is taken away, but if I'm the lady who brings the chicken to the markets to sell them and I don't own a car, what will happen to my cost of selling my chicken at the market if the minibus gets more expensive because diesel is not subsidized anymore, right? So these are the practical questions that we need to think about how we can model them. There's another line of literature that then rather looks at the behavioral response. That tends to be rather macro-level CGE type studies, which are also very important, but they lack the granularity of understanding at the distributional and subpopulation level what's happening. So in this work, we're trying to assess the direct and the indirect effect. And we are looking at the 4 countries in the Andean region that are part of the Southmont project at this point. And we focus on gasoline, diesel, and natural gas. And particularly the natural gas is, of course, a bit a different animal than gasoline and diesel, because, again, it also has a lot of health implications. It's actually something we don't want people to go back, cut the woods, and burn that for cooking either. So you already can see there's a lot of granularity even in the fuel subsidies that one can think of. Then we assess in how far one could recycle the money that didn't go to the fuel subsidies in order to offset the loss to households. We also try to take into account here the effect of prices on real incomes. Now, we will go more into the methodology, but obviously by what I was just charting out is we have, luckily, a very detailed body of modeling sitting in the Southmont model. So we understand the benefit structure in a country. We also understand the other taxes, so we can actually evaluate the overall impact at that level. And that's very important to understand, because you will see that in the social protection reforms that we propose, we, for example, propose rather simple reforms that could be more practically implementable, like just increasing the benefits to people who are already receiving a benefit, which is way simpler than starting a fully new benefit. But we can also, with this model, do like, what if we could target very, very specifically the bottom quintile of the distribution? We can also do that type of reform that rather gives you more the space in which a policymaker could think about his reforms. So overall, this paper uses really the strengths of the South models, and it's a trailblazer in the sense that also as of June we will release the models up till 24 with 24 modeling in earlier years. As of 22, the models where relevant will include fuel subsidy modeling. So anyone publicly can download the models and work with them. We'll do a similar analysis also for Rwanda and Ethiopia, where there's also fuel subsidies in the model family that we have here. And I already mentioned the call that we will have coming forth, and I think, it's a very interesting line of work that connects not just to this session, but many other fields of work here. And with that, I leave all the difficult stuff to David.
The idea here is that we are going to combine the tax benefit microsimulation models that we have for the Andean region, for 4 countries in Latin America. And also, we are going to use input-output tables to elicit the direct and indirect effect of removing fuel subsidies in the region. So we are going to have 5 steps. First of all, we are going to use the South models that we updated to include fuel subsidies. The idea here is that the fuel we are going to compute as a difference between the price, the international price of the fuel, and the internal price of the fuel in each of the countries. So with this difference, we are going to compute the percentage change in the price. In the next step, we are going to use the inverse Leontief matrix. That is, we are going to take the input-output structure of the 4 countries, and we are trying to elicit the increase in prices in all other sectors when we increase the price of each fuel. And something that we have to take into account here is that we are going to keep the quantities that each household consume constant. So the idea is that they are going to purchase the same things, but they are going to pay more for each of these things. So this exercise gives us the indirect effect, because within the model we can calculate the direct effect, that is just removing the subsidy. After that, the idea is that we are going to see how much they have to pay for their expenditure, the direct and indirect effect. And also, within the models, we are going to try to compensate the households, mainly at the bottom of the distribution, for the removal of fuel subsidies. As Pia explained, it's a bit complicated, the analysis of fuel subsidies, because on the one hand, you have gasoline that is used, for instance, for transportation, and this is going to affect the price of the items that the households buy. But also, we have gas that is mainly used for cooking in the region, so there are different kind of effects that we expect when we analyze the direct and indirect effects. And at the final step, we are going to compute this effect of prices, as we are computing changes in prices, not only in fuels, but also in some other goods. The idea is to try to see the real effects of this change in prices. So the idea is we have, typically in the microsimulation exercises, we have disposable income, and in this case we are going to define consumable income, and we are going to use a price index to try to capture the changes in the purchasing power of income. So as I said before, we have a static model. We are going to assume within this exercise with the input-output matrix that all the change in prices is going to go to consumers. That is, firms are going to translate all the price increases to consumers. They are not going to keep any of the change in fuel prices. And we are going to keep quantities that household consume constant. So from the methodology, we have the tax benefit models. We updated them to have fuels, to include this fuel subsidy policy. We have data for 2022. And within the model, we have direct, indirect taxes, and also benefits. And for the input-output part, we have taken the input-output matrices from the JITA project. JITA project has social accounting matrices, but we extract the input-output part just to make this exercise of obtaining this inverse Leontief matrix that is going to give us the increase in prices. So typically in microsimulation models, we compute this disposable income measure that is like market income plus benefits plus pension income. We subtract social insurance contributions and subtract direct taxes, income taxes mainly. But in this case, as we are trying to analyze expenditure, we define consumable income. And so we take disposable income and add benefits. In this case, fuel benefits is what is going to come here in this V uppercase upper int. And we subtract taxes. In this case, taxes are mainly VAT. So the idea is we have this definition of income. Consumable income is our measure of welfare. But in this analysis, we are increasing the prices of fuels and other things. So this definition of income is incomplete if we don't take into account that each, I don't know, for instance, in Colombia, the metric is pesos. So for instance, 100 pesos is not going to buy the same quantity of goods as before. So what we are doing is using this stone price index that is just a geometric index of the prices, one for each household, and we kind of deflate the value of this consumable income. So we are trying to capture this purchasing power. In this case, the purchasing power of each household is going to decrease because prices are going to increase. So this consumable income is going to be in real terms lower when we use this price index. So now for the results, this is the percentage increase in expenditure after the reform. We can see for the 4 countries different patterns. In the case of Peru, at 2022, we didn't have any fuel subsidy in place. There is some kind of fuel subsidy in Peru, but it is kind of a band. And the idea is that for the exercise, we simulated an increase in fuel prices of 10%. So in Peru, actually, we don't have this fuel subsidy, but we try to simulate what will happen if we increase the fuel's prices in 10%. So we see very different results. For instance, the blue bars are the direct effects, the gray bars are direct effects, and we see that it changes a lot between countries, and also the direct and indirect effects are different within each country. For instance, the total effect in Bolivia is going to be a 10 to 12% increase in expenditure. Remember that the quantities are fixed. So the idea is that 12% is going to increase the value of expenditure. In Colombia is less, and we don't see kind of a pattern there. And in Ecuador is a bit lower the effect. Should I continue? I can continue, okay. So the higher effect we see is for Bolivia, and well, for Peru is just a 10% increase, so the effect is lower. We also analyze the effect considering each fuel apart, gasoline and diesel on one side, and natural gas and liquefied petrol gas in the other. And we see that, for instance, for gasoline, the indirect effect is higher in Bolivia, but the direct effect is lower. So the idea here is that this change in the price of gasoline is going to increase the price of other commodities, not that much the gasoline itself is going to affect the household. And for Colombia, on the other hand, the effect is higher, the direct effect is higher than the indirect effect. So in this graph, we try to decompose these effects. Remember that the definition of income that we are using is consumable income. So we have 4 effects in place. One is the price effect. So for instance, this is the effect of the change in the purchasing power of income. On the other hand, we have the increase in VAT, because if households keep quantities fixed and the price increases, they are going to have to pay more taxes. On the other part is the fuel subsidy itself. So when they remove the subsidy, consumable income is going to decrease. And in the last part, we simulated several compensation scenarios. In this case, in this graph specifically, we are giving a lump sum bonus to those that are currently receiving benefits in each country. So the idea here is that we are taking the beneficiaries of social benefits in each country. They are typically at the bottom of the distribution. In Latin America, these transfers are targeted mainly at the bottom. And we are using the existing benefits that each country provides. And for each recipient of benefits, we are going to give kind of a bonus, increasing his disposable income and his consumable income. In this case, the idea is that we are not compensating exactly those affected, but we are using the existing system in place to give additional transfers to the poor, mainly. And so we have all these 4 effects. Benefits are going to increase consumable income, but the other 3 are going to decrease consumable income. So we can see that the bars are going to the negative side, but benefits are going to the positive. And when we add up all these effects, we have the circle, that is the total effect. So when we take into account all these effects, we can see that, for instance, in Bolivia, throughout the distribution, everybody is worse off when we give this transfer. But for instance, in Colombia, as benefits are very targeted at the bottom of the distribution, for the first quintile, we observed that the consumable income increases in 12 or 13%. In Ecuador, just the first quintile is better off, and in Peru, just the first quintile is better off. And we have another scenarios. In this case, we just compensate exactly those who lost consumable income at the bottom of the distribution. In this case, in this other scenario, they are all worse off. And also we have winners and losers in terms also of consumable income. And we see that despite we are trying to compensate recycling all what the government receives, removing the fuel subsidy, most of the people around in the distribution is worse off after the simulated reforms. So I don't know if Pia wants to go back to the conclusion. So we also analyze the effects on poverty and inequality, and the idea is that despite that we are recycling in some scenarios all the resources that the government receives from removing the fuel subsidy, is difficult to reach to the bottom of the distribution if we use the transfers that are in place. In some cases, well, in some of the countries, as we saw around here, they are going to be better off, but the rest of the distribution, they are going to be worse off. Yeah.